fire service is full of amazing people, individuals of such character who risk personal health and safety for the citizens they serve. Frequently, tasks like ventilation, forcible entry, fire behavior, butting a ladder are completed without fully understanding how they affect the dynamics of the overall fire scene. Throughout my career as a firefighter, I've had countless discussions with other firefighters as to why we do certain things. So instead of giving them the typical line of tradition or that's the way we've always done it, whenever possible, to bring a better understanding to their question, I try to couple my answer with a visual demonstration. I think most firefighters are visual learners, including myself. If I see something done, then I have a better understanding of how it works. Through a variety of experiments and demonstrations, we are able to better understand a theory or concept behind something that may be otherwise difficult to grasp. You might be surprised at some of the results, and hopefully you'll remember them when working at the next fire scene. And remember, gauges don't lie. We are all familiar with standpipe systems. We see them on calls, building inspections, and pre-fire plans. It's important to remember when dealing with these systems the effect that elevation has on pressure. A fundamental principle taught to pump operators is the amount of pressure needed to raise water above the pump, as to supply pressure to nozzles that are operating above the pumper. It takes 0.434 psi to overcome gravity and raise water 1 foot high. Conversely, 1 foot of water exerts a downward force of about 0.434 psi. Here's a simple demonstration of this principle. Okay, what we've made here is a simulated standpipe riser, and we've marked it off in 1 foot increments starting at 0, 1 foot, 2 foot, and we even put one -1 foot as we went below grade level. And the pressure gauge has a tube connected to it, and inside the tube you can see the water level. And let's see what happens now when the water level is even with the gauge. It reads 0. As we know, as we raise water above the level of the pump, the pressure will increase. And you can see that at the 1 foot mark, we have a downward pressure of 0.434 psi. And as we go to the 2 foot mark, you can see the gauge reads 0.868 psi. And this relationship continues. What do you think is going to happen now when we bring the water level below the level of the pump? Let's go to -1 foot. Now we have a gain in elevation, and you can see that the gauge reads -0.434. So we have an elevation gain. So how can we apply this relationship to firefighting? Well, let's assume a fire is on the 15th floor of a high-rise building. Based on what we just learned, let's determine the pressure needed to raise water from the pumper to the fire floor. For ease of calculating, we'll assume each story is 10 feet high. Therefore, the fire floor is approximately 150 feet above the pumper. Knowing that it takes 0.434 psi to raise water 1 foot, then if we multiply 0.434 by 150, we determine the pump operator needs to add an additional 65 psi to the pump pressure just to raise water to overcome gravity. For fireground purposes, pump operators are taught to round 0.434 psi to 0.5 psi per foot when figuring elevation. This is for gain or loss. In this example, the elevation loss would be 75 psi.